So now we're going to see how significant figures can be incorporated in different calculations that we'll be exposed to in chemistry. Now, we're going to start out with multiplication and division. We're going to say when either multiplying or dividing different numbers, the final answer will contain the least significant figures. And if we take a look at this example, it says, perform the following calculation to the right number of sig figs. Here we have three values that are being multiplied together. We have 3.16 times 0.003027 times 5.7 times 10 to the negative 3. We just said that when you're multiplying or dividing, it's least number of sig figs for your final answer. So we need to determine the number of sig figs for each value. From our topic on significant figures, we know that if we have a decimal point, which all of them do, we move from left to right. Now remember, we're going to start counting once we get to our first non-zero number. Here, 3 is our first non-zero number. And once we start counting, we count all the way into the end. So 1, 2, 3. This has 3 sig figs. For the next one, skip, skip, skip. Our first non-zero is this 3. 1, 2, 3, 4. This has 4 sig figs. And then finally, we have 5.7 times 10 to the negative 3 written in scientific notation. Remember, when it's written in scientific notation, just focus on the coefficient. We're going to say our first non-zero number is this 5. And once we start counting, we count all the way into the end. So 1, 2. This has 2 sig figs. Now, based on our sig figs of 3, 4, and 2, we have to go with the least number of significant figures. That means our answer at the end can only have 2 significant figures. So when we first get our answer, what we see initially is 5.45222324 times 10 to the negative 5. We want 2 sig figs here. That 4 that we have, though, we look to the right of it and see if we either keep it as 4 or we round up. Next to it, we have this long string of numbers, and we have a 5 there. Because that number is 5, that means we have to round up. So the 5.4 becomes now 5.5. And then times 10 to the negative 5. This represents our answer, which has the least number of significant figures based on the initial values given. We were given these 3 numbers initially, and the one with the least number of sig figs was the one written in scientific notation. So that tells me that my final answer has to have that number of significant figures. Now that we've looked at multiplication and division, let's go on to our next video, and let's see what happens when we incorporate addition and subtraction. Now, when either adding or subtracting different numbers, the final answer will contain the least decimal places. If we take a look at this example, it says, perform the following calculation to the right number of sig figs. Now, if our answer is based on the least number of decimal places, that's going to have a direct impact on the number of significant figures. If we take a look here, it says we have 402.09 minus 2.12.2 plus 2.671. If we look at these values, this one has 2 decimal places, this one here has 1 decimal place, and this one here has 3 decimal places. Based on that, we're going with the least number of decimal places. Our answer can only have 1 decimal place at the end. When we punch all this in, we get 192.561. We can only have 1 decimal place. To the right of that 5, there's a 6 there. That means we have to round up. So this is 192.6 as our final answer. And if you wanted to talk about the number of sig figs, you'd move from left to right. Our first non-zero number is this 1. And counting all the way through, we'd have 4 sig figs at the end. Okay. By following this least number of decimal places, it has a direct impact on the number of sig figs in our final answer. Up to this point, we've kept multiplication and division separate from addition and subtraction. But what happens when you mix them together? In this video, we're going to take a look at mixed operations. Now, we're going to say here, when dealing with a mixture of multiplication, division, addition, and subtraction, we must follow the order of operations. To do this, we use PEMDAS. PEMDAS stands for parentheses, exponents, multiplication, and division, and addition / subtraction. If we take a look here, it says perform the following calculation to the right number of sig figs. All right, so if we look here, we have in parentheses this operation, and then in another set of parentheses, this operation. So we're going to do each parentheses separately initially. Now in the first parentheses, we have subtraction going on. Remember, when we're doing addition or subtraction, it's least number of decimal places. Initially, we're going to write down what do we get in our calculator. So when I do 8.829 minus 6.5, I get initially 2.329. Now we're going to do what's in the other parentheses. Here we have addition, so again, it's least number of decimal places. What we're going to do initially, though, is write down what we see in our calculator. So we're going to see 4.030. Now, least number of decimal places. This has 1 decimal place. This has 3. We're going to go with 1 decimal place. So this becomes 2.3. Over here, we have 2.920. Here we have 0.11. We have 3 decimal places, 2 decimal places. So my answer has to have 2 decimal places. So this becomes 4.03. So at this point, we've done what's in the parentheses. We'd follow the rules in terms of sig figs when it's addition and subtraction. Now at this phase, we're multiplying. We're going to multiply these two numbers together. So what I'm going to do here is I'm going to write down what we see initially when I do 2.3 times 4.03. So initially, I'm going to see 9.269. But remember, what is the rule when it comes to multiplication and division? The rule is our final answer is the one with least number of sig figs. So if we take a look here, we're going to say that this number, 2.3, has a decimal. When it has a decimal, we're going to go from left to right. We're going to start counting once we get to our first non-zero number and keep counting until the end. Here's our first non-zero number, 1, 2. This has 2 sig figs. This one has a decimal point as well, so we're going to go from left to right. First non-zero number is this 4, so 1, 2, 3. This has 3 sig figs. Least number of sig figs will be our final answer. This has 2, this has 3. The least number of sig figs would have to be 2. So now that would mean my answer of 9.269 has to change to 9.3 because this has 2 sig figs. So for this problem, our final answer will be 9.3. Our final answer has 2 significant figures.